Today I'll be covering how to simplify complex fractions in order of operations with fractions. To start off, to simplify complex fractions, we have two methods. The first method is simplify the numerator and the denominator into a single fraction and then multiply by the reciprocal of the bottom fraction. And I'll just go through it. Oh, and a complex fraction is where you have a fraction on top and the bottom of another division bar. So now for method 1, simplify the numerator into one fraction. Already done. Simplify the denominator into one fraction. Already done. Then we're using the principle that this says this fraction divided by that fraction. So let me write that out. This is just divided by that fraction. So when you do division, remember, you keep the first fraction the same, change it to multiplication, flip the second fraction. Nothing simplifies, so 1 times 5 is 5, 3 times 2 is 6. So 1/3 over 2/5 is equal to 5/6. So let's do that for B also. First you want to do is simplify this into one fraction. Well, a whole number minus a fraction. So I'm going to put the whole number over 1, so I have two fractions. Now when we subtract fractions, you need an LCD. The LCD between 1 and 2 is 2. 1 times 2 is 2, so 3 times 2 is 6. And nothing changes there. I have to do the same thing with the denominator. The LCD between 1 and 5 is 5. Nothing changes on the second fraction, but 1 times 5 is 5, so I have to multiply 4 by 5. Now I have 6 minus 1, which is 5 halves, 20 plus 1, which is 21 fifths. Again, when you get one fraction on top, one fraction on the bottom, take the first fraction, multiply it by the reciprocal of the second fraction. So the reciprocal of 21 over 5 is 5 over 21. Nothing simplifies. 5 times 5 is 25. 2 times 21 is 42. So 3 minus 1/2 over 4 plus 1/5 equals 25 over 42. As you notice, when you aren't already given a single fraction in the numerator and denominator, method 1 takes a little longer. Now what method 2 does is you take the LCD of all the fractions, you multiply the numerator of the big fraction and the denominator of the big fraction by the LCD. So if I look at A, the LCD between 3 and 5 is 15. So I'm going to multiply the top by 15 and the bottom by 15. As you can see, by doing this, 15 over 15 is 1. So I'm not changing anything. So 15 times 1/3. Well, the third goes to a 1, the 15 to a 5. So I'm left with 5. 2/5 times 15. Well, the 5 goes to a 1 because 5 goes into 5 once, and 5 goes into 15 3 times. Then we have 2 times 3, which is 6, which was the same answer that we got over here. Now for B. The only fractions we have in this complex fraction is the 1/2 and the 1/5. So what's the LCD between 2 and 5? 10. So I have to multiply the whole numerator by 10, the whole denominator by 10. Well, 10 times 3, because we have to use our distribution property, 10 times 3 is 30. Then 10 times 1/2, or 1/2 of 10, is 5. Sometimes you might have to do that multiplication off to the side, but I just knew 1/2 of 10 was 5. Down here, 10 times 4 is 40. 10 times 1/5. So let me do that over here. 10 times 1/5. 5 goes in 5 once. 5 goes in 10 twice. 2 times 1 is 2. So 30 minus 5 is 25. 40 plus 2 is 42. 25 over 42. So no matter which method you use, you will get the same answer. You just pick which one you use. You can use it either one. It's just your preference. So now on to order of operations. Example 3 is just to work these out. So remember, order of operations is PEMDAS. So parentheses first. So I have to do 5 minus 1/2. In order to subtract fractions, I have to make the whole numbers into a fraction. Now the LCD between 1 and 2 is 2. Everything else I'm leaving the same. Nothing changes here, so it's 1/2. But I had to multiply the 1 by 2, so I have to multiply the 5 by 2, which is 10. Now 10 minus 1 is 9 halves. Now that the parentheses are done, I move on to exponents. There aren't any exponents. Then I go to multiplication and division from left to right. So if I multiply these two fractions, I see that the 2's cancel out, leaving me with 9/5 minus 1. Now all I have left is subtraction. I have to make the whole number into a fraction, get an LCD of 5. Nothing changes here. But I had to multiply this by 5, so I have to multiply the numerator by 5. So 9 minus 5 is 4/5. So keep track of your steps and show as many steps as possible because the least likely you'll make a mistake. Now B. Again, I have to do parentheses first. So I'll do this set of parentheses. In order to do this set of parentheses, I need an LCD, which between 3 and 6 is 12. Between 3 and 6 is 6. The LCD is 6 because 3 goes into 6. So nothing changes here, so it's 1. But 3 times 2 is 6, so 1 times 2 is 2. Now 1 plus 2 is 3/6 cubed. So you see how I'm just going to work this set of parentheses out, then I'll come over here and work this set of parentheses out. I'm not forgetting it, it's just I know I have to finish this parentheses. And now I notice that 3/6 simplifies to 1/2. So now over here, I don't have addition, I just multiply across, but I'm going to simplify first. 2 goes to 1, and 4 goes to 2. So now 1 times 3 is 3. 5 times 2 is 10. Now I'll just drop that down because nothing changes. Now here, it's going to be 1/2 times 1/2 times 1/2 plus 3/10 times 3/10. Because a third power means I have it 3 times multiplied. Second power means I have it twice multiplied. So 1 times 1 times 1 is 1. 2 times 2 is 4. Times 2 is 8. 3 times 3 is 9. 10 times 10 is 100. Now to add these, I need to find an LCD between 8 and 100, which I don't know what it is. So I'm going to go over here and do a factor tree of 8 and 100. Well, 8 is 2 and 4, which is 2 and 2. 100 is 2 and 50, 2 and 25, which is 5 and 5. And actually, let me do this up here more. 100, 2 and 50, 2 and 25, 5, and 5. So now I have 2 and 5 as my only factors. I have 2 2's here, 3 2's here, so I need 3 2's. 2 5's here, 0 here, so I need 2 5's. So now 2 times 2 times 2 is 8, times 5 times 5 is 25. So now 8 times 25, or 8 quarters, is $2, or 200. So that means I need an LCD of 200. Well, as I just said, 8 times 25 was 200, so 1 times 8 is 8. 2 times 100 is 200, so 9 times 2 is 18. 8 plus 18 is 26 over 200. Can reduce it by 2 to get 13 and 100. So our final answer is 13 over 100. So as you can see, these get pretty lengthy, and if you don't have enough room, it gets a little messy. I hope you can follow this. Just bring lots of paper. I only have so much space on the board. Now over here, see, we do have to do parentheses first. So let's do these parentheses. What's the LCD between 10 and 20? 20. Nothing changes here, but 10 times 2, so 1 times 2. So 2 plus 3 is 5 out of 20, which is, well, 5 goes in 5 once, 5 goes in 24 times, 1/4. Here I'm going to make the 1 into a fraction. The LCD is 5. Nothing changes here. 1 times 5 is 5, so 1 times 5 is, again, 5. Now 1 minus 5 is -4 over 5. So times -4 over 5. 4 goes in 4 once. 4 goes in 4 once. So 1 times -1 is -1. 1 times 5 is 5. So the answer is -1/5. That one was a little shorter. Exponents